All right, this is going to be AP Calculus, Lesson 5-6. We are talking about the analytic definite integral. And where are we in the unit guide? We are right here, analytic definite integral 5-6. And look at this, we are on our new power standard M, the definite integral. All right, so welcome back from the break. Hopefully you have all of your homework done up through 5-5, notes and worksheets. Let's go ahead and do the setup, pause me now, and then let's go ahead and get started. All right, so let's talk about the different types of integrals. Generally speaking, there are two types of integrals. There's indefinite integrals and definite integrals. So this is what we've already been doing. I mean, you can see in our unit guide, we've been doing antiderivatives so far. So this is the antiderivative that we know and love. And when I say indefinite here, what do I really mean? Indefinite means that I don't know where I start or end. So this is kind of an unknown. It's a general one. So we'll say unknown. So indefinite, I don't know the start or end. So unknown, and you can maybe put over here, you can say start/end. Start/end. All right, so now let's talk about the definite integral, what today's lesson is about. So the definite integral, another way of saying that is it's just the integral, so aka the integral. So you generally assume when I say integral, I'm talking about the definite integral. All right, so definite. What is another way to think of definite? That's where you have known start and end points. So this is, we'll say, known. And again, we can say start and end if you don't know what known means. We know where it starts and ends, where the function begins. So start/end. And eventually I'll be giving you a picture, not in this lesson, but in a future lesson. Please don't write this down in your notes, just to give you a heads up. So generally speaking, you have your function, say it looks like this, and we can say, okay, we're going to start right there and end right here between A and B. And then I need to find the value between these two values, even though the function goes on and on beyond that. So that's just giving you a heads up on what's to come. So let's go ahead and draw a picture of what this looks like. So we'll switch to block here. So for an indefinite integral, that will look something like this. I'll have, I don't know, some integral of, we'll just say a general f of x dx. And then when you take the indefinite integral, you'll find this turns into antiderivative of lowercase f is capital F of x, and don't forget your plus c. And that's basically the whole procedure there. So what does the definite integral look like? So let's take an integral over here, another integral, and we'll say same thing, f of x dx. But now we're saying, where does it start and end? We now know the start and end. So we're going to say it starts from A, and we'll put A right here, and it ends at B, from A to B. That's how I read this. So let's read this together. This is the integral from A to B of f of x dx. And I'm going to go ahead and annotate this too so that we can have it in our notes. So this A, that's your start. This B right here, that's your end. And then we have this thing. This is what you're, okay, I can draw my curly brace correct. This is going to be the actual function that we take the integral. So we'll just label that. That's what we're actually integrating. Integrate that guy. All right. So once you have this function, what does this turn into? This turns into capital F of x plus c. This guy turns into, well, we need to evaluate it first. So I'm going to do 2 lines here. This is going to turn into, so another capital F of x, and instead of saying plus c, it's going to be evaluated between A and B. So to say that, we need to do our evaluation bar. So it just looks like that. It's a giant bar, kind of looks like absolute value, but one side. And I'm saying I'm going to go from A to B. So start is always on the bottom, end is always on the top, from A to B. So now this is an evaluation. The integral sign is gone. It's kind of gotten flat, I guess, on the right-hand side. And then we need to actually evaluate what that is. And the way that I do this is saying plug in B and plug in A and then subtract them. So I'll write that for you here. So this turns into, and I'm kind of getting low on room. I don't want to run into my procedure. Actually, it should be fine because the procedure is only like a few sentences. So this turns into f of b. We put in b into x, so we evaluate for whatever that number is. It'll turn into like pi or some number like 3. And then you're going to subtract when you sub in f of a. So you plug in lowercase a into your function, you'll get some number out, and then you do the end minus the start. F of b minus f of a. It's not the start minus end, it's end minus start. Okay. So what is the general procedure for taking the definite integral? I kind of went over it informally here. Let's make it a little bit more formal. So step 1, take the antiderivative. So take antiderivative. Generally speaking, that is the hardest step. If you don't have all of these other lessons mastered from 5-1 to 5-5, that first step is going to be really, really hard. And then from here on out, it's our new procedure. So we need to plug in start/end. So plug in, I'm going to say end and start, not start and end, because it's the end first and then the start. And then finally subtract. And you will get a number. This will not be a function that you're evaluating. This is probably some number like 32. That would be your answer for the definite integral. All right, so let's move on to the next slide. And this should be the final slide. I just want to go over some examples. This is definitely a one-pager, maybe even a half-pager. So I have 4 examples, technically 3, and then 2 parts of the third. So go ahead and copy this down, and let's begin. So our first problem, number 1. This guy, what is he going to turn into? Well, I need to derive him, take the antiderivative. So when I take the antiderivative of 3x squared, this is going to go up a power, x to the power of 3, x to the power of 3, and I divide down. 3 divided by 3 is 1, so there's nothing out in front here. I could do a 1. And I don't do a plus c now. I say I have my antiderivative, and I'm going to evaluate him from 1 to 3. From 1 to 3. All right, so now I'm plugging in 3 into x, and if you don't know what's going on here for your notes later, you can say I'm taking this number and I'm plugging it in for x. What does that look like? So this is going to turn into 3 cubed. And I'm also going to plug in this 1 into x. I'm going to subtract when I plug in 1 cubed. 3 cubed is 27 minus 1 cubed, which is 1. That is equal to 27 minus 1, which is turning into 26. And let's go ahead and box our final answer. All right, number 2. Step 1, take the antiderivative, and that is often the hardest step. So what house are we in? We're in E house, tree house. So we're going to take the u is going to be our 3x squared, or 3x. Remember, I'm using u substitution because when I take the derivative of the inner, 3x is the inner, the derivative of 3x is 3, it's not 1. So if it's not 1, use u substitution. So that means that I'm going to say that my u is equal to 3x, and my du is equal, and you can use Taxman here if you want. I'm doing u substitution because that is formal math and what is going to be tested on the AP exam. So du is going to be 3. So I need to, du dx is equal to 3. Du with respect to whatever is here. And I need to solve for dx. I need to find dx to plug in to here. So dx is going to equal, and that's going to be du divided by 3. Okay, so using all of that, we get my new integral is, I'm still rewriting the integral from 2 to 3, and I'm going to come back to this in a sec because this is not really true math anymore, so I'll come back and explain why. So this is going to be 6e, and it's not 3x, it's to the power of u, and that's going to be times dx, but dx is really du over 3, times du over 3. All right, and then that will eventually simplify to 2e to the power of u du. But there's something that's wrong here. For the definite integral, these numbers here, they're in terms of x. This is really saying if I have an integral, and please do write this down, if I have the integral of, I'm going to give yourself some room here, like 2 and 1 from 1 to 2, this is really saying, and it's some function, we'll say like f of x dx is a function of x. That is really saying x goes from 1 to 2. That's not saying u goes from 2 to 3 now. So if you see on the AP exam where they give you u's, just know that your original values that they gave you are switched now, and I can teach you how to switch them. You just switch them using this equation. Like this was 3, so plug 3, it was x equals 3, so x equals 3, plug that into here, and this will be now 9, because 3 times 3, and then u is equal to 9. So this really should be from 6 to 9, if I was being formal about this. I don't really care about that for now. We'll touch on this at another point. But just note that these are in terms of x, not u. All right, so now we have our u substitution done, and let's take the antiderivative. Oh, I want to switch my colors here. So taking the antiderivative, I get, this was a 2e to the power of u. So e house stays the same, so it's going to be still 2e to the power of u. And now I need to evaluate from 2 to 3. But there's a problem here. As I said, these are x equals 2, x equals 3, so if I plug them in for u, I would get the wrong answer. So I need to undo subbing in for u. So here we go. I'm going to go to the, I think I have enough room on this line. So this is going to turn into 2e, and it's no longer u, it's to the power of 3x. Now sub that, substitution bar, write that, and then 2 to 3. All right, so finally, this is going to become 2e to the power of, and I'm going to sub in my end first, my top first. 3 to the power of 3 is 9, so 2e to the power of 9 minus 2e to the power of, and I'm subbing in this 2 for x, and that's going to be 6. 2e to the power of 6. And can I simplify these? I could factor out a 2, but I think that's as far as we can get. We'll say that is our answer. All right, number 3. So here I'm going to take the antiderivative. Antiderivative is step 1, and that's going to get rid of a prime. So I'm going to be left with f prime of x from 1 to 2. And that's going to turn into f prime of 2 minus f prime of 1. Pretty straightforward. Just remember that it goes to a lowercase f from a lowercase f. It only goes to a capital F if you ran out of primes to take away. Okay, so you might be asking, why did I write the same problem twice? And this is to show you that, or show you why we don't have to write plus c. You might have been thinking, this should have been 26 plus c. This should have been all this plus c. This should have been all this plus c. Here is why that's not the case. Let's go ahead and write the plus c and see what happens. So taking the antiderivative, this is going to be f prime of x plus c evaluated from 1 to 2. Okay, so let's evaluate that. What is that going to turn into? That's going to be f prime of 2 plus c. So that's the whole first substitution. That's subbing in 2. Now we're going to subtract subbing in this 1. So this is going to be f prime of 1 plus c. I just substituted everything in again. And notice here, this is going to be, if I simplify this, I'll do this on this bottom line. This is going to turn into f prime of 2, and then plus c minus c. This negative is distributed into each of these terms. This is going to be c minus c, which is 0. There's no c term. This is just f prime of 2 minus f prime of 1. Same thing. So that's why we don't write the plus c. All right, that's all I have for us. Go ahead and write your summaries.